Ashe. I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic Applied Electronics Information session produced by our esteemed elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the current limiter. Applied electronics technicians play a crucial role in ensuring the proper functioning of electronic equipment in various industries. One important component that technicians need to be familiar with is current limiters. Current limiters are devices used to limit the current flowing through a circuit to prevent damage to components and equipment. In this essay, we will explore what applied electronics technicians need to know about current limiters. One of the key things that technicians need to understand about current limiters is how they work. Current limiters are typically designed using either passive or active components. Passive current limiters, such as resistors, are simple devices that limit current by dissipating power in the form of heat. Active current limiters, on the other hand, use semiconductor devices such as transistors to actively control the current flow in a circuit. By understanding the basic principles behind current limiters, technicians can effectively troubleshoot and maintain electronic equipment that uses them. Technicians also need to be aware of the different types of current limiters available and their applications. The most common type of current limiter is the current limiting resistor, which is used to limit current in simple circuits. Other types of current limiters include active current limiters, such as current limiters with overcurrent protection, which are used in more complex circuits to provide additional protection against overcurrent conditions. By having a good knowledge of the various types of current limiters, technicians can select the right type of limiter for a particular application and ensure the proper functioning of electronic equipment. In addition, technicians should understand the importance of proper sizing and placement of current limiters in electronic circuits. Current limiters are designed to protect components from damage due to excessive current flow. It is crucial that technicians properly size the current limiter to ensure that it can effectively limit the current in the circuit without causing voltage drops or other issues. Additionally, the current limiter should be placed in the circuit in a way that ensures that it can detect and limit overcurrent conditions quickly and effectively. By understanding the importance of proper sizing and placement of current limiters, technicians can ensure the reliability and longevity of electronic equipment. Another important aspect that technicians need to consider is the thermal management of current limiters. Current limiters dissipate power in the form of heat when limiting current flow. It is crucial that technicians understand how to properly dissipate this heat to prevent overheating and damage to the current limiter and surrounding components. This may involve using heat sinks, fans, or other cooling methods to maintain the temperature of the current limiter within safe limits. By understanding the thermal management of current limiters, technicians can ensure the proper functioning of electronic equipment and prevent potential failures due to overheating. Current limiters are essential components in electronic circuits that protect components and equipment from damage due to excessive current flow. Applied electronics technicians need to have a good understanding of how current limiters work, the different types available, and their applications. They should also be familiar with proper sizing, placement, and thermal management of current limiters to ensure the reliability and longevity of electronic equipment. By possessing this knowledge, technicians can effectively troubleshoot, maintain, and protect electronic equipment in various industries. Current limiters are a crucial component in many electronic devices and circuits. They are used to protect components from damage due to excessive current flow, as well as to maintain stable operation of the circuit. Understanding how current limiters work, the different types available, and how to troubleshoot and maintain them is essential for applied electronics technicians. Passive current limiters are the simplest form of current limiting devices. They work by dissipating power in the form of heat when the current flowing through them exceeds a certain threshold. A common example of a passive current limiter is a resistor. Resistors have a fixed resistance value, and when the current passing through them reaches a certain level, they generate heat to limit the current flow. However, passive current limiters have some limitations, such as limited precision in controlling current levels and the potential for overheating and failure if the current exceeds the resistor's power rating. Active current limiters, on the other hand, use semiconductor devices such as transistors to actively control the current flow in a circuit. This type of current limiter can provide more precise current limiting capabilities and can respond more rapidly to changes in current flow. Active current limiters are commonly used in applications where precise current control is required, such as in power supplies and motor control circuits. One of the key things that technicians need to understand about current limiters is how to calculate the appropriate current limit value for a given circuit. This involves understanding the maximum current rating of the components in the circuit, as well as the operating conditions of the circuit. By calculating the appropriate current limit value, technicians can ensure that the circuit is protected from excessive current flow while still functioning effectively. In addition to understanding how current limiters work and how to calculate the appropriate current limit value, technicians also need to know how to troubleshoot and maintain current limiters in electronic equipment. When a current limiter fails, it can result in damage to other components in the circuit, so it is important to quickly identify and replace the faulty current limiter. When troubleshooting current limiters, technicians should first check for any visible signs of damage, such as burnt or charred components. They should also measure the current flowing through the current limiter using a multimeter to determine if it is operating within the specified limits. If the current limiter is found to be faulty, technicians should replace it with a new one of the same type and value. Regular maintenance of current limiters is also important to ensure the continued safe and effective operation of electronic equipment. This can involve checking the current limiters for signs of wear or damage, cleaning them to remove any dust or debris that could affect their performance, and testing them periodically to verify that they are functioning properly. Understanding current limiters and how they work is essential for applied electronics technicians. By knowing the basics of current limiters, technicians can effectively troubleshoot and maintain electronic equipment that uses them, protecting the components in the circuit from damage due to excessive current flow. With the increasing complexity of electronic devices and circuits, it is important for technicians to stay current on the latest advancements in current limiting technology and techniques to ensure the continued safe and reliable operation of electronic equipment. Applied electronics technicians play a crucial role in the maintenance and repair of electronic equipment in a wide range of industries. From troubleshooting and diagnosing issues to making necessary repairs and adjustments, technicians must possess a thorough understanding of electronic principles and components. One key area of knowledge that technicians must have is an understanding of current limiters and their applications in electronic circuits. Current limiters are devices used to limit the amount of current flowing through a circuit to prevent damage to components and ensure the proper operation of electronic equipment. Technicians must be familiar with the different types of current limiters available and how they are used in various electronic circuits. The most common type of current limiter is the current limiting resistor. This type of current limiter is a passive device that is used to limit current in simple circuits. Current limiting resistors are typically used in LED circuits to prevent excessive current from damaging the LED. Technicians must understand how to calculate the value of the current limiting resistor based on the desired current flow and the characteristics of the circuit components. In more complex circuits, active current limiters are often used. These current limiters incorporate additional features, such as overcurrent protection, to provide enhanced protection against overcurrent conditions. Active current limiters can detect when the current flowing through the circuit exceeds a predetermined threshold and can quickly limit the current to prevent damage to the components. Technicians must be familiar with the operation of active current limiters and how to select the appropriate type for a particular circuit. Proper sizing and placement of current limiters are critical to ensuring the effectiveness of these devices in electronic circuits. Technicians must ensure that the current limiter is sized correctly to limit the current flow without causing voltage drops or other issues in the circuit. Additionally, the current limiter must be placed in the circuit in a way that allows it to detect and respond to overcurrent conditions quickly and effectively. By understanding the various types of current limiters and their applications, technicians can select the right type of limiter for a specific circuit and ensure the proper functioning of the electronic equipment. This knowledge allows technicians to troubleshoot issues related to overcurrent conditions and make necessary adjustments to prevent damage to components. Furthermore, technicians should be aware of the implications of not using current limiters in electronic circuits. Without a current limiter in place, excessive current flow can lead to components overheating, voltage spikes, and other issues that can damage the electronic equipment. By incorporating current limiters into circuits, technicians can provide an additional layer of protection for the components and ensure the longevity of the equipment. Applied electronics technicians must possess a solid understanding of current limiters and their applications in electronic circuits. By knowing the different types of current limiters available, how to properly size and place them in circuits, and the consequences of not using current limiters, technicians can effectively protect components from overcurrent conditions and ensure the reliability of electronic equipment. With this knowledge, technicians can confidently diagnose and resolve issues related to current flow in circuits and contribute to the smooth operation of electronic systems in various industries. In order to operate effectively in the field of applied electronics, technicians must possess a broad range of knowledge and skills. One important aspect that technicians need to be well-versed in is the thermal management of current limiters. Current limiters are crucial components in electronic circuits that regulate the flow of electricity, preventing damage to sensitive components and ensuring the safe operation of the system. However, when current limiters are in operation, they dissipate power in the form of heat. It is essential for technicians to understand how to manage this heat effectively to prevent overheating and protect the current limiter and other components from damage. When current limiters are subjected to excessive heat, they may malfunction or even fail completely. Overheating can cause a variety of issues, including increased resistance, reduced performance, and in the worst-case scenario, a complete breakdown of the component. In order to prevent these problems, technicians must be able to effectively manage the heat generated by current limiters. One common method of managing heat in electronic components is through the use of heat sinks. A heat sink is a passive cooling device that is attached to a component to dissipate heat and maintain the temperature within safe limits. Heat sinks are typically made of materials with high thermal conductivity, such as aluminum or copper, and are designed to maximize surface area for efficient heat dissipation. Technicians must understand how to properly select and install heat sinks to ensure that current limiters operate at optimal temperatures. In addition to heat sinks, technicians may also employ active cooling methods to manage heat in current limiters. Fans are commonly used to increase airflow around components and dissipate heat more effectively. By incorporating fans into electronic systems, technicians can enhance cooling performance and prevent overheating. However, technicians must also consider factors such as fan placement, size, and speed to ensure that cooling is optimized without creating additional noise or vibrations that could impact system performance. Another important consideration for technicians is the thermal resistance of current limiters. Thermal resistance is a measure of how effectively a component can dissipate heat and is a critical factor in determining the operating temperature of the device. By understanding the thermal resistance of current limiters, technicians can evaluate their heat dissipation capabilities and make informed decisions about how to manage heat effectively. This knowledge is essential for preventing overheating and ensuring the longevity of electronic components. Furthermore, technicians should also be aware of the impact of ambient temperature on the thermal management of current limiters. Operating electronic equipment in environments with high temperatures can exacerbate heat dissipation issues and increase the risk of overheating. By monitoring ambient temperature and taking appropriate precautions, technicians can minimize the impact of external factors on the thermal management of current limiters. In conclusion, thermal management is a critical aspect of maintaining the reliability and performance of current limiters in electronic circuits. By understanding how to effectively dissipate heat, technicians can prevent overheating and protect components from damage. Through the use of heat sinks, fans, and other cooling methods, technicians can ensure that current limiters operate within safe temperature limits and contribute to the proper functioning of electronic equipment. By acquiring expertise in thermal management, technicians can enhance their skills and contribute to the success of electronic systems in a variety of applications. Thank you for participating in this majestic Mind Matters University Basic Applied Electronics Information session. We appreciate your engagement and sincerely hope that this information will help propel you to a better understanding of basic applied electronics. Like, subscribe, and share to stay updated on our upcoming sessions and help spread knowledge in electronics. The title for this basic applied electronics session was Introduction to the Current Limiter. Stay woke. Ashe.